Hello everyone, welcome to MindSpan Education. So if you are following this playlist, you would be able to make the connection. So how we started with the basic probabilities, right? And afterwards in the basic probabilities we looked at the conditional probability. So there is two part. One is ordinary probabilities, and afterwards we looked at the conditional probabilities. And these conditional probabilities are nothing, they are just like ordinary probabilities. So in conditional probabilities we just need to find the probabilities under given some condition. So might be with the ordinary probabilities we will have some universe, and now we have some condition or we have some given event. Then what we do, we find the conditional universe, and within this conditional universe we find the conditional probabilities, right? And we have understood this in very detailed manner. Now we have gone through the discrete random variable, and we saw the PMF, that is the probability mass function. And these PMFs are what? These PMFs are nothing but these are also probabilities, right? And we have seen the ordinaries PMF, and again we have the conditional PMF as well. So what are these conditional PMF? These conditional PMFs are nothing but probabilities under some given event, under some given condition, or under some given evidence, whatever you would like to say, right? And since so again, how would you find the conditional PMF? So you will have the initial PMF or the ordinary PMF, right? What you will do, you will simply, based on the condition, you will revised all the probabilities, and those revised probabilities will be the conditional probabilities. So initially you will have some PMF. Based on the condition, what you will do, you will make a conditional universe, right? And in this conditional universe, whatever the probabilities you will find, that will be called as a conditional probabilities in terms of the conditional PMF, right? And since we have gone through these random variables, discrete random variable, we have also seen the ordinary expectation, right? And if we are in the conditional universe, we will be talking about the conditional expectation, right? We have seen the ordinary variance. Now if we are in the conditional universe, we will be talking about the conditional variance, right? So it is all about finding the probabilities, right? Just you need to observe. If it is a ordinary case, then take the whole universe, and if it is a conditional case, then as per the condition or as per the evidence, just consider that conditional universe, and within that conditional universe make the revision of the probabilities, and those revised probabilities will be called as conditional probabilities. And if you are talking about the random variables, then there would be some few important quantities that we calculate, like expectation. So if you are in ordinary universe and calculating the expectation, that then it would be a ordinary expectation. If you are in conditional universe and finding the expectation, then it would be a conditional expectation. Same for the variance, right? Now since we are going through the continuous random variable, we have seen for the continuous random variable we have the probability density function, right? And in last of the few videos we have seen what are these probability densities function of a different random variables, right? A special kind of different random variables, we have already seen that, right? Now how we have done in case of the discrete case, the similar thing we are going to do in case of the continuous case. So how we have gone through the probability mass function in case of the discrete, and afterwards we have gone through the conditional PMF. Similarly, we have already seen the PDF of a single continuous random variable. Now we are going to look at the conditional PDF. Right? I hope if you are following this playlist, then you should be able to make the connection that how the flow of lectures are going on. Alright, so let me first of all recall you the few of the things from the discrete case, and you will see it is nothing in discrete case, since this everything is in discrete, so that is why we are using the summation sign. And there we have the PMF, that is the probability mass function. You will see the similar thing in case of the continuous random variable. We will just have the, in place of the summation we will have the integration, and in place of the PMF we will have the probability density function, right? So if we have, let's say, if in case of the discrete case, if we want to find the probability that random variable, any discrete random variable x takes the value little x, right? And if we have to write this in terms of the PMF notation, that is the probability mass function notation, how do we write this? We can simply write this small p. So small p, we have considered or make the convention that it will be denoting the PMF, right? And subscript would be whatever random variable we are working with, or whatever random variable we are talking about, and this PMF will be the function of this little x. So what we have done, we have done nothing. We have this probability, right? We want to find this probability. We have make the another notation, and that notation what we are going to call as a PMF notation, right? Similarly, the same thing we have seen in case of the continuous, right? But in case of the continuous, let's say if you want to find, you can find the probability of the exact point, but that we have already seen in case of the continuous random variable, that if you want to find the probability that random variable takes the value, exact value, any, then this probability will be 0. The very first lecture of the continuous random variable, I have gone through this point, and I have described you in a very detailed manner that why the probability of a single point is 0, right? So instead of talking about a single point, what we do, we talk about the probability in a certain range, right? So in case of the continuous random variable, instead of asking the probability at a fixed point, what we do, we talk about that, we say that random variable, let's say if this random variable x is a continuous random variable, then this random variable takes the value that is greater than equals to x and less than equals to x plus delta, right? So random variable takes the value within certain small range. What's the probability of that, right? We cannot denote in case of the we can do it, but probability would be 0 if we directly ask that what will be the probability that this continuous random variable takes the value, any certain value little x, then this probability will be always 0, right? And why, look at the first lecture of this continuous random variable, you will get the idea why at a certain point of this continuous random variable the probability will be 0. So instead of talking about the certain point, what we do in case of the continuous random variable, we consider a certain range. So this is x, then let's say this delta is a small some quantity, then this will be x plus delta. So we are finding the probability of this particular range, right? So this probability, we have here the PMF notation, right, in case of the discrete, but we have already seen we have the PDF, and the PMF directly gives you the probability, that but the PDF, the probability density function, is not the directly probability. They are probabilities per unit length, right? So this is the probability, right? So we cannot say directly that this PDF will give you the probability, right? So you will have to multiply the length also, right? So up to what length we are calculating the probability? So this is x and this is x plus delta, so up to delta length. So you have to apply or multiply this delta also with this PDF in order to find the probability. Otherwise we have already seen that this PDF is not exactly the probability. They are probabilities per unit length in case of a single random variable. We will see in case of multiple random variable as well, but you got the point, right? These are not exactly the probabilities. That PDF probability density function is not exactly the probabilities. They are probabilities per unit length, right? And if we have to find this probability in case of the continuous random variable, then we can get it from the PDF, right? And why we have multiplied this delta? Because this is probability per unit length, then this length will get cancelled, you will have the probability. Okay, now coming to again the discrete part. Let's say if you have given some event, right, and given some event you want to find the probability that random variable takes the certain value. So we have already seen that given some event, the conditional probability, now we are talking about the conditional PMF or the probabilities. Given some event, let's say if I ask you what will be the probability that random variable x takes the value little x, what's the probability of that? And if you have to denote this as a PMF notation, and that PMF would be a conditional probability mass function, right? So we have already seen, so since we are talking about the PMF, so we will be using little p, and we are talking about the random variable x, but not under some condition. So this is how we can write. We are talking about not only the random variable x, but under some, we are talking about this random variable x, but under some condition. So we will have to indicate this, that what we are talking about, right? And it will be again the function of this little x, right? And similarly, if we have to write the same conditional PDF in case of the continuous random variable, how we can write? So now let's say again that there is some event A, and that event A is given to us, right? And now under this given condition we want to find that the probability. So under this given condition that A has occurred, what's the probability that random variable takes the value greater than equals to x and less than equals to x plus delta, right? And if we have to denote this, so we cannot use directly the PDF, we will have to use this with multiplication of the length, otherwise the PDFs are not exactly the probabilities, they are probabilities per unit length. So again the notation would be like this. So small f, that means we are talking about the probability density function, and we have this, we are talking about this random variable x, and we are talking under some given condition, right? And it will be the function of this little x times delta, right? So in this lecture what we are going to talk about is about this conditional PMF, conditional probability density function, that is PDF. So we will be deriving the formula for this conditional PDF, right? And also in case of the discrete, if let's say if we want to find the probability that random variable x takes the certain value. So let's say if we want to find the probability that random variable x belongs to some set b, right? So random variable will be taking some value. How do we find? So what we do, simply we sum all the probabilities that this random variable x can take from this set b, right? And if we have to find the probability, let's say if we have given some event that a has occurred, under this condition, if we have to find the probability that random variable takes the value from this set b, right? Now instead of using this ordinary PMF, what we will do, we will simply what we will be doing, under this condition we will have the revised probabilities, right? And those revised probabilities are nothing but the conditional probabilities. So we are going to revise all the probabilities under this condition, and those will be the conditional probabilities given this event A has occurred. And if we are interested in finding that this random variable belongs to this particular set B, or random variable takes the value from this set B, so we are going to sum all the probabilities that random variable x belongs to this set B, not the ordinary probabilities but conditional probabilities, right? We have seen the several examples based on that. Here we have the ordinary probabilities because we have no condition. Here we have the conditional probabilities, and these are the revised probabilities based on this given condition. And once we have the revised probabilities, and if we have been asked that random variable x belongs to some set B, or random variable x takes few values that are in set B, then we just need to sum up all these conditional probabilities. Then you will have the probability that random variable x belongs to set B, right? Similarly, we will have, if we ask that what will be the probability that this continuous random variable belongs to some certain range, let's say B, how we are going to find this probability? We are simply going to integrate the ordinary PDF over this range, whatever the B have range, right? Then we will have this probability. Now let's say if we want to find this probability, and we have given some condition that this A has occurred, so what we are going to do, simply we are going to make revision of our probabilities. So in case we will have the revised PDF, right? And this revised PDF is nothing but the conditional PDF, and we are going to integrate over this range of value that whatever the B have, right? And again, these conditional probabilities are the legitimate probabilities. That means if you sum over all the possible values of the probabilities of these conditional probabilities, then that should add up to 1. Similarly, in case of the continuous random variable as well, right? So these conditional PMFs are the probabilities in the conditional universe. That means they should be a legitimate probabilities, and if you add all the probabilities, or if you integrate the conditional PDF from all possible values, then they should add up to, or they should integrate to 1, right? So you see, we, in case of the discrete and in case of the continuous, what we have done, we have done nothing, just we have replaced the summation to integration, and PMFs to PDF. Now let's look at what will be the conditional PDF. So we want to find this conditional PDF. So let's first of all talk about. So let's find out this PDF, this conditional PDF. I hope you are comfortable with this equation. So we are finding this probability that random variable takes this value given this condition. What is this condition? Condition is that random variable x belongs to this set A. So either you say that this event A has occurred, this is given, or you say that event that this random variable takes the value from this range A, or this x belongs to this range or set A. All these sayings are the same, all at the end saying that event A has occurred. Right, under this condition we have to find this conditional probability, or this probability that random variable takes the value from x to x plus delta. Right, and this same probability is here written in terms of the PDF notation. How we can proceed further? We can make use of the conditional definition. So this conditional probability, that will be equal to the probability of happening both the events. So probability that random variable takes the value from little x to x plus delta, and this random variable x takes the value from this set A, or this event A has occurred. Happening of both these events divided by the probability of the conditioning event. The conditioning event is that probability that this random variable x takes the value from this set A, or this event probability of happening of this conditioning event, that is event A. Right, on the right hand side we will have the same probability but in terms of the PDF notation. Now let's look at this event, or this event of this probability of this event. So let's say if we have this PDF of this random variable x of maybe this kind, what we have given? We have given that this random variable x takes the value from a certain range. And one more point, just as a note, we are still talking about a single random variable, right? So we are conditioning, we have the same random variable, right? And here we are asking about the probability of this random variable x that falls within this range, and we have also given that probability of this random variable x conditioned on this event, right? So we are talking about a single random variable. Once we will go through the joint random variables or joint PDF, then we will be talking about the given some event or given some another random variable, what's the probability of another random variable, right? So we are talking about just a single random variable, right? So what's the conditioning event? That this x belongs to this set A, or x takes the value up to certain range, right? So maybe we have this condition that this is the range of A, right? So whenever random variable x takes the value within this range, we say that this event A has occurred, right? So this is the condition we have given. Now under this condition we have to find this probability, right? So, and from the definition of this conditional probability, so there might be case that whatever the condition we have given and whatever the probability we are interested in, those will not have any common part, or those will not have any intersection, right? So this is the condition we have given. So might be whatever the interested probability that we want to find after imposing this condition, this interval may not fall within this range. So maybe this x and x plus delta would be somewhere around outside this interval here, or maybe on this side. So there would be no probabilities, right? Because this intersection, there will be nothing, something that is common. So the probability of that event would be 0, right? So if this x and x plus delta is outside this conditioning universe, then the numerator part will be 0, right? Or we might be, so overall point is that if they are outside the interval of this range of this conditional event, then their probability would be 0. The conditioning probability would be 0. It might have happened that the interested probability after imposing this condition, they might fall within this range, right? Then the intersection of these two will be this, right? So that would be equal to probability that random variable takes the value from little x to x plus delta divided by this conditioning probability, right? And this can be written as the PDF value at x times delta divided by the probability of this event A. This delta will get cancelled. So from here, this conditional PDF that would be equal to the unconditional PDF divided by the probability of this conditioning event. So here we have the formula for the conditional PDF, that this will be 0 if the whatever the probabilities we are interested in, if that doesn't belong to this range A, then it will have the 0 probabilities, and it will be equal to the unconditional PDF divided by this conditioning event if whatever the range we are interested in after imposing the condition belongs to the range of the conditioning event, right? So the point here is that this is unconditional probability, right? And you see it is 0, that whenever the probabilities which we are interested in after imposing this condition, if they fall outside this interval, then it will have the no common part. That means the probability of happening of that event will be 0, right? And whenever we have the whatever the event we are interested in, if that falls after imposing the condition, if that falls within that range, it will have the some PDF. So that PDF might look like this, right? And outside this we have the 0 conditional probabilities. If you observe here this is the unconditional PDF, right? And this quantity is scaling this unconditional PDF. So overall this factor is what is scaling the shape of the PDF, or ultimately if I have to say, this is the revised PDF after imposing or after given some condition, right? So this is the complete whole revised PDF after given this condition. I hope it makes sense. If you have any question, let me know in the comment section or maybe in the group. We have also seen the expectation and the conditional expectation in case of the discrete random variable. So how we can find if we have some discrete random variable x and if we want to find the expectation of it, then it is this is how we can find the expectation of the random variable, discrete random variable, right? And we have also seen the conditional expectation. Let's say if we have given some event a, we want to find the expectation of this random variable x given this condition. So while finding the expectation when we have no condition, then we are using the ordinary's PMF, right? And if we have some condition, what we will be doing? We will be using some revised PMF or the conditional PMF. Similarly, for the continuous case, if we have to find the expectation of this continuous random variable, we can simply integrate this term and we will have the expectation, right? And if we want to find the expectation of this random variable x given some condition or given some event, then instead of using this ordinary PDF, what we are going to use is the conditional PDF, right? And this will give you the conditional expectation. We can extend this idea. We have already seen the expected values rule, that using the expected value rule we can find the expectation of a function. So in the ordinary case, this is how we find in case of the discrete. So we just need to have the ordinary PMF, then we will be able to find the expectation of any function using expected value rule. And if we want to find the expectation of this function under some given condition, then instead of using this ordinary PMF, we are going to make use of the revised PMF, that is the conditional PMF. And once we have this revised PMF, we can find the conditional expectation or of this function. Similarly, we will have the same analogous thing here. If we want to find the expectation of any function, then using the expected value rule we can find it if we have the PDF, ordinary PDF. And if we want to find the expected value of this function under this condition or under this event A, then in that case we need to have the conditional probability density function. And once we have this conditional probability density function, we can easily find the expectation of this function, right? So overall point is that whatever you have learned so far, the concepts, the intuition in case of the discrete random variable, that you need to carry out, right? And because in discrete case all these are easy to visualize, right? And once you have the understanding of this, then you can make use of that understanding to extend the idea in case of the continuous random variable. So if you observe here, we have done nothing. What we have done, we have simply changed the summation sign to the integration, and the PDFs, the PMFs to the PDF, right? Otherwise, the core concept, whatever we have learned in case of the discrete, that will remain same, and we are going to rely on that. I will be taking an example in next video based on this conditional PDF in case of the continuous random variable. Thank you so much.